Well, good morning, ladies and gentlemen, and welcome to this webinar this morning. My name's Adam DeMarco. I'm the host and the founder and the CEO of The Urban Developer, and I'm delighted that we've been able to bring together a really interesting topic for discussion this morning. What lies beneath? What developers need to know about basements and groundwater in New South Wales. We've had some interesting conversations that sit behind this, and we're delighted to be able to get cracking. Big shout out as well to our partners who are hosting us, hosting this event with us, the Dincel Structural Walling company, and we're delighted to be able to sort of present what they do as well in response to this very important topic, which you'll be hearing a bit more from Steve and their team this morning as well. A very warm welcome to all of our TUD Plus members. TUD Plus is our professional membership for property. Very warm welcome to all of you. And if you're interested in finding out more about what we do, please just reach out to our team as well. Shout out to our long-term charity partner, the Property Industry Foundation. Help us help them address youth homelessness by supporting what they do as well. And again, don't forget to share your thoughts and opinions on social media throughout the course of the day. And we'd love to be able to track what you think about this and plenty more. So get involved in that. Bit of a shameless plug for our awards. They're coming up. Nominations are now open. They're the industry's largest and most coveted awards program. So please, if you get the opportunity, if you've got a project or a team of people that are doing amazing work, recognise them through the Urban Developer Awards for Industry Excellence. And again, then let's get straight into it. I'm delighted to welcome both Steve Darwell, who's the Chief Operating Officer at Dincel Structural Walling, and Lee Douglas, who's the Principal Hydrogeologist at Reditus Consulting. Now, one of the interesting things when we had this conversation initially, we became aware that there was some important legislation working its way through New South Wales, which put greater responsibility on both developers and those that are involved in the project downstream to effectively protect against groundwater issues on their site. The group, the team from Dincel came to us and said, guys, the industry needs to be aware of this. So we're delighted to be able to partner with this great company to present this to you, and hopefully you walk away with a better and a deeper understanding of it. What we're going to do is we're going to start with Lee's presentation. He's going to sort of set the scene, and then Steve will sort of expand upon this more technically and also demonstrate how their particular solution addresses some of these concerns. A little about Dincel. They were founded in 1989 and originally specialised in structural and design engineering work. In 2006, they developed the Dincel Structural Walling System, which is a PVC-based permanent formwork system, and have been able over now 20 years to develop that as a solution for the industry. So you'll hear plenty about that today. I won't go any further with any of that, other than to say, Lee, welcome, and Steve, welcome, and welcome to all of you for tuning in. We're going to get straight into it, and Lee, I'm going to hand across to you first to set the scene.
All right, great. Thanks, Alex. It's a pleasure to be here. I'm Lee Douglas, founder of Reditus Consulting, and I'm a principal hydrogeologist with over 20 years of experience. So to kick it off, the reality is groundwater is often thought as out of sight and out of mind, and it's always treated as an afterthought. But I have firsthand that ignoring it or cheaping out on the groundwater issues can lead to significant costs and program delays. So to start us off this morning, I wanted to touch on some of my experiences with construction dewatering, where things can go right and where things can go terribly wrong. So all of the dewatering issues I come across can broadly be categorised into three main divisions. So firstly comes the poor planning, which results in development delays. So not understanding the assessment approval requirements and not understanding the timeframes it takes to get those approvals. And I'm talking massive delays in your construction program. I'm not talking days, I'm talking in terms of months to half a year. The second issue I commonly see surrounds dewatering uncertainty. So that's where you can get over predictions of dewatering requirements. Now, these result in unnecessary and excessive costs, whereas conversely, there's also under prediction of dewatering requirements. Now, these often result in unexpected construction delays, massive cost variation, changes to your building design and modification approvals, and in some cases, some developments have become financially unviable. And then thirdly, we see the overlooked groundwater risk. So this is where major failures happen due to poor groundwater assessment and dewatering management, where it's resulted in significant structural damage, both on-site and off-site, disrupting people's lives, costing millions in damages and legal fees, and not to mention your reputational damage. So let's start with examples of poor planning. And I kid you not, I've had sites on airports, massive council projects where they're laying kilometres of pipelines. I've had tier 1 and tier 2 developers. They come to me, they've got civil contractors engaged on site, waiting to dig. However, no one's considered getting the approval. And when I talk to them and explain how long this takes, they fall off their chair and cannot believe the process and how disruptive this becomes to their development program. So Steve's going to expand more on this today based on the New South Wales perspective. The next issue revolves around not adequately understanding the development constructability with the actual groundwater conditions. So I've got so many examples where the development design has been based on over-predicted groundwater inflows or non-existent hydrostatic pressures. So we've come onto projects where the building design has not been based on the actual hydrogeology of the site, and we've managed to come in, and I kid you not, savings in the developments of between $1 and $50 million, depending on your scale. So there's a lot of value lost in oversizing dewatering equipment, oversizing water treatment plants, over-engineering structural features, and this compounds blowing out project timelines. Just a quick example in Monterey, down in the Botany Sands, the developer had a preliminary geotech report predicting 1.5 gigalitres of inflow, and this was contaminated with PFAS. They were getting quotes in excess of $900,000 for the treatment cost alone, but we managed to come in, taking a look at the groundwater from a hydrogeological perspective, and managed to save significant money on their program, like over $500,000, and reduce the time frame. So conversely, there's the other issue of under-predicting the groundwater conditions and what's required in construction. So I've had a site in the Gold Coast recently on the Nerang River. It's also near the beach. They majorly underestimated the dewatering requirements to drop the water table. We had to upsize it by over 500%. It cost major variations and blew out the construction timeline. And then finally, there's the development sites where major failures have occurred, where groundwater risks have not been understood or managed appropriately. You're probably all aware of the Mascot Towers incident and the damage done through neglect of important dewatering issues, structural failure of a neighbouring site, 131 units uninhabitable, $15 million in damages, legal fees, and not to mention reputational damage. I've had similar issues in Double Bay, where heritage buildings have suffered differential settlement due to poor management of groundwater drawdown. And I've also had sites, one site in Double Bay, where the approved development had significant dewatering requirements. They'd gone through approval, they've done their design, they've spent a lot of money, but when it come to constructing it, the whole project become financially unviable and the developer ended up walking away. So like, what a waste. I wish they'd come to me sooner and I could have advised them on how to deal with the dewatering issues. So don't make high cost decisions on poor groundwater information. I'll now hand over to Steve and he can walk through the specific New South Wales approval process.
Well, thank you, Lee, and thanks, Alex, too, for allowing Dincel to undertake this presentation today on the design and approval of developments that impact the aquifer in New South Wales. The situation we're in at the moment is we've got increased densification leading to an increase in basement excavation. Many areas the water table is relatively close to the surface, and the design of basements need to take into account the impacting the aquifer both during construction and also for the duration of construction. And we've found that many developers and specifiers are unaware of the New South Wales legislation that must be addressed when the aquifer is impacted. Now, in pulling together this presentation, we've engaged with pretty much all councils in the Greater Sydney region, with hydrogeologists and with architects. And particularly we engaged with Water New South Wales, and the information that I'm about to present has been reviewed by and had input from Water New South Wales. Now, there are four major pieces of legislation or documentation that impact construction in New South Wales. There's the Water Management Act, water sharing plans, the minimum aquifer interference policy, and the minimum requirements for building groundwater investigation. Suffice to say, the legislation is quite complex and convoluted. The minimum requirements document is a guide to assist developers in the legislation. Now, critically, it states that the best practice is engineered drainage around and under a drained basement. Further, to Lee's point, the site hydrogeology report in support of the application must be technically robust and comply with all aspects of the legislation. The application must demonstrate that there is no more than minimal harm as a result of any activity. And if that can't be proven, then it won't be supported. And aquifer interference activities must be licensed to take into account the water taken and must have approval and designed to manage to ensure that there's no impact. Now, as Lee mentioned before, I would certainly recommend that you need a skilled hydrogeologist to navigate the path effectively. Also, of course, other requirements that need to be taken into account is developers need to understand the specific basement design requirements of some councils. There are a number of councils in New South Wales that require a tanked basement when the water table is impacted. Indeed, there's one council that requires a tanked basement if you're just going to be digging a basement. And specific consideration needs to be taken into account in terms of council constraints on the disposal of groundwater to stormwater, both during construction and post-construction. And critically, we need to take into account the NCC requirements relating to mould, because certainly some basements design will create a humid environment which could lead to mould. Now, the process overview. There's a two-stage process within New South Wales. Now, stage one, proponents should have proposal reviewed by Water New South Wales and the New South Wales Department of Conservation, Environment and Water via the integrated development process. The review at this stage is to ensure that the development complies with all aspects of the legislation before DA and will avoid any of those costs further down the track that Lee alluded to. Now, referral at this stage isn't mandated. However, referral at this stage could, and in many cases does, lead to problems and delays prior and down the track. Now, Water New South Wales actually advises councils that whether or not developers have taken the integrated development process, they should still review it. Stage 2, and prior to the commencement of works, the proponent must apply for and be granted a water supply work approval, and works cannot commence without a water supply work approval. If the project wasn't assessed previously, it's going to be assessed at this point in time. And the project will be assessed in exactly the same way as stage 1. And it will be assessed prior to a water supply work approval being granted. So a range of conditions will be applied at this point in time, potentially unforeseen. And it will certainly delay construction as a minimum and could indeed require for the project to be redesigned. In effect, there's a third and relatively complex stage that a drain basement needs to undertake, and I'll cover this a little bit later. Now, it's worthwhile pointing out that each of stage 1 and 2 assessments can take anywhere from a few weeks to many, many months, depending on the complexity of the hydrological assessment needing to be undertaken. Now, if I could just make a point about the post-DA stage water supply work approvals. Now, these 3 points come from an actual presentation from Water New South Wales from September 2025. In summary, the 3 points are: it is the proponent's responsibility to get a water supply work approval prior to construction, and without one, work is illegal. And also, a water supply work approval will not be granted if the basement design does not conform with the council requirements, and if the council approval for the water disposal is not part of the application. Now, there are 2 different sorts of basement designs that you can move forward with. There's a tanked basement and a drained basement, and both of them have different approval processes. Now, under a tanked basement, only a during construction water management plan will be required for a tanked basement. A tanked basement is only going to have standard general terms applied for construction, and then there will be no conditions applied post-construction by Water New South Wales. Standard GTAs include simple issues such as stating that the water take must be recorded, council requirements must be met, all licenses and agreements must be granted before construction, and so on. Tank basements critically are not referred to DQ by Water New South Wales at DA stage, as there is no aquifer impact post-construction and hence no need for complex hydrological analysis. This makes the process a quick and simple process. The tank basement prior to work commencing, as I stated, prior to work construction commencing, developers must apply to Water New South Wales for a water supply work approval, and the approval must be granted before construction commences. Most tank basements are deemed low risk and therefore are not submitted to DQ for review at this point in time. That makes approval relatively quick. Further, there is no requirement for post-construction. A drain basement is somewhat more complex. Drain basement applications have to prove to the satisfaction of Water New South Wales and DQ that the project will have no more than minimal impact on the aquifer, or they will be refused. Now, understand, all drain basement applications will be referred to DQ. Drain basement applications must not only have a detailed during construction water management plan, but they must also have a detailed and documented management plan for the life of the building. And it is documented in the guidelines that is 100 years. DQ and Water New South Wales will also include various conditions depending on the project to include together with the GTAs. In particular, it will require for the water take to be recorded annually and reported for the life of the building. And it may be required that aspects related to maintaining and draining the basement are also reported. Assessment will, in all probability, be lengthy due to the complexity of the hydrological assessment. It should be noted too that drain basements will, in all probability, create a humid environment, which could promote the growth of mould, and this would be, in many cases, in contravention of the NCC. This indeed could be a far more pertinent issue than all the requirements regarding the conforming to the appropriate legislation. A fully tanked basement will not create a humid environment and as such would not fall foul of any NCC requirements. Prior to and post-construction. Prior to construction, developers must apply to Water New South Wales for a water supply work approval, as with tanked basements. But in addition to Water New South Wales, they will also be referred to DQ. And again, that's going to take a significant greater period of time than for a tanked basement. The third approval stage that I alluded to previously is that post-construction and prior to OC, the developer must resubmit for review and approval the post-construction water management plan. Water New South Wales and DQ at this stage, and reviewing the management plan, may approve the plan, could approve the plan with additional conditions and requirements, or potentially could reject the plan and require modifications and resubmission. Again, this process is going to be potentially lengthy and problematic. Then, prior to OC, if the development is going to take more than 3 megalitres per annum, the developer must apply for and receive a water extraction licence to take water for the life of the project. OC will only be given once there's a fully approved life of project water management plan. If at any time during the life of the project the water take exceeds the approved water take, the project must be resubmitted to Water New South Wales and DQ for reassessment. This could lead to potentially significant remediation works to be undertaken by the ultimate owner. The ultimate owner will be responsible not only for the recording and reporting of water take, but also for the maintenance of the infrastructure related to the associated drained basement. These potentially onerous and costly reporting and maintenance requirements would not be part of a tank basement development. Now, water take during construction. Recently, legislation has been changed such that in Metro Sydney, water take during construction is unlimited. In other locations, you still have to follow the process previously described. Projects still need to be reviewed by Water New South Wales. The assessment process by Water New South Wales will be exactly as per the previously described, depending on whether it's a tanked basement or a drained basement. Particularly, this will include a during construction water management plan with particular emphasis on the environmental impact of and disposal of large water tanks. During construction, there's no need for a water access licence, but there will still need to be a water supply works approval from Water New South Wales and DQ. It should be noted that records of water must still be kept and council must still approve the disposal to stormwater if this is the proposed disposal method. Now, water take less than 3 megalitres per annum post-construction. Drain basements that take less than 3 megalitres per annum are treated slightly differently. They still need to be referred to Water New South Wales. Assessment by Water New South Wales will be relatively quick. There is no need for a water extraction licence. Councils must still approve and apply conditions to disposal to stormwater. And of course, I just need to re-emphasise that disposal to sewerage is illegal. All issues relating to a drain basement still remain. Water management plans post-construction must be submitted and approved prior to receipt of OC. The building owner is responsible for recording and reporting water take, and the building owner is responsible for maintaining drain basement infrastructure. And of course, if at any time for the life of the project, post-construction water take exceeds 3 megalitres, the project must be resubmitted to Water New South Wales for reassessment. So in summary, any project that impacts the aquifer, the life of the project must be assessed by Water New South Wales and DQ to ensure that project has minimal impact. The approval process is two-stage. Assessment on the impact for application of GTAs and conditions and the granting of water supply work approval. All projects must have a during construction management plan, but in addition, drained basements must have a comprehensive post-construction water management plan for the life of the project, and an OC cannot be granted unless the plan has been approved. So ergo, the best course of action, in our view, is a tanked basement. A tanked basement has minimal impact on the aquifer and as such meets all requirements of Water New South New South Wales water legislation. It's the preferred construction methodology of Water New South Wales and DQ. In almost all cases, it will only be assessed by Water New South Wales. It will only have standard GTAs during construction and will have no GTAs post-construction. The approval process will be quick and simple. It aligns with the design requirements of many councils within Sydney. It requires no ongoing recording of water take or maintenance cost. And critically, it will not create a humid environment and as such will not promote the growth of mould. For those that may be listening from Victoria and Queensland, I'm no expert in this area, but I can offer the following observations on the topic. In Victoria, only one council mandates that for basements to be tanked, and that's the City of Kingston. Most councils do not allow discharge to stormwater during construction. Disposal to sewer via a trade waste agreement and or off-site disposal or approved on-site reuse are the preferred methods. Post-construction, no discharge to sewer or stormwater is allowed. There must be on-site reuse and or off-site disposal. This poses significant long-term cost risk. The best option, therefore, would be a tanked basement. In Queensland, minimum requirements for groundwater disposal either during or post-construction. However, there's an increasing perception that water in the basement is unacceptable. So a tanked basement, again, is the best low-risk option. Now, Dincel provide a waterproof basement system that is low cost and fully warranted for 50 years. The components of the system are a patented Dincel water stop that is cast into the basement slab. The protective cover is removed from the DWS and an ejectable hose is placed within the DWS. The Dincel wall is erected and filled with self-compacting concrete. When the structure is fully loaded, resin is injected into the hose, sealing off the wall to the footing slab interface at the pressure side. If at any time during the life of the building a leak happens to appear, the system can be re-injected and the leak sealed. Dincel has had an independent quantity surveyor undertake a cost comparison of the Dincel system against conventional tanking systems. Now, most pertinent for this topic is the analysis found in submerged conditions. It found that the Dincel system is 17% cheaper in sandy soil and 28% cheaper in stiff clay, hard shale and sandstone. So finally, the Dincel waterproof basement is the best choice and a tanked basement is the best choice. Dincel provides the best, lowest cost option for a tanked basement. We provide up to a 50-year leak-free warranty. Only one entity is responsible for the waterproofing integrity of the basement, as opposed to conventional waterproofing where three parties, the product supplier, the product installer and the builder, will argue against individual responsibility should a leak eventuate. If for some reason there is a leak, it can be repaired from the inside of the basement with minimal, if any, impact on the building occupants by simply re-injecting at the point of leakage. And water is stopped at the pressure face, both initially and at the time of any repair, ensuring a fully dry wall and as such, zero possibility of mould growth. I have gone through this detail relatively quickly, so I look forward to listening to and answering your questions. Thank you.
Thank you so much, and a really valuable conversation. I've got some projects on at the moment where these are considerations that you really start to feel the pressure of once you're well into the project, and that's where I kind of want to start, because a lot of developers really sit at the front end and aren't necessarily thinking about whether their basement solution is tanked or drained. And so, I really want to start at that early phase. And it's a question to both of you, Steve, and to Lee. I mean, what advice or what recommendations do you have, practically for developers at the front end of a project when they're contracting the land to consider this? How can you practically recommend for this to be on their mind? And I guess what can they do in the very early phases to get some comfort over which solution is the right solution.
Yeah. Maybe I can start there.
Yeah.
No.
Yeah. So, like, as a hydrogeologist, I'd strongly recommend that any developer engage someone that specializes in the groundwater, not just the geotech. They sort of do overlap, but they are specialized disciplines. So getting a hydrogeologist in the feasibility and due diligence phase of your conceptual planning, how you're going to construct the building, and we can provide advice on your likely inflows, the constructability of the development, the cost implications on how you want to construct it. So, and I'm not just saying it, but there are potential big savings and cost avoidances that can be taken if you do it correctly.
Steve?
Certainly, I would echo what Lee is saying, because in our experience, when we've gone into the basement and there have been issues on developments, it has predominantly been because a skilled hydrogeologist hasn't been engaged right up front, so that for developers to understand the impact on the way through.
So that's all well and good, but obviously you got to spend money. So on these experts to be able to do that, and there's that balancing point between finding a site, finding an opportunity, and deploying all of your consultant fees before that's a live deal. What are some of the early indicators then? And let's use New South Wales and Greater Sydney as an example. Like, what parts of town or what parts of the city are more likely to be affected by this and less likely? And if you could go maybe round the ground, Steve, I'll start with you.
Certainly, in our experience, well, there are 7 councils within the Sydney metro area that require for a tanked basement to be used in every case where you impact the aquifer. And they're the usual suspects, if you like. The Northern Beaches Council, as you know, everywhere up there, it rains a little bit and there's flooding, the stormwater system overflows. So they're particularly concerned about the impacting groundwater and then pumping out from a drained basement into the store and overloading the system. In Wallara Council, they require that you tank a basement no matter what. Then there's certainly the Botany Sands area is a critical area for water. Down in Wollongong, even in Penrith, there's a requirement there when you hit the water table. And in the Penrith area, the water table is relatively high, so it's not hard to hit that water table when you're impacting when you go down into the basement. And so there's those 7 councils. You can critically say, well, they've got that in there because there's a water table that's relatively high, and you can see that by investigating council requirements. But Lee, maybe you can add some other areas that may well be impacted by water in any significant way.
I think you mentioned the main zones, Steve, in Sydney, where you have high permeable unconsolidated sands, where you get a lot of groundwater inflow. One of the things you always need to be aware of, particularly in the metro areas, is the contamination aspect. So this always catches people and blindsides them. You may be dewatering a site near an old service station or a chemical facility where you're dewatering, and then suddenly you start pulling in vast amounts of chlorinated solvents, or diesel and petrol start coming in, and that's when the costs for water treatment and water disposal just can blow your budgets right out. So knowing that sort of information before you get on site, before you start putting in your shoring and temporary dewatering systems, you got to understand maybe there's a better way to do this. Maybe there's a better way to avoid pulling in all this water. You can redesign the extraction system so it maintains your excavation level, and also design it so you're avoiding these contamination areas. That's one area where I see people getting unstuck in the metropolitan areas.
Yeah, Lee, just expanding on that, because I know that Steve touched on Victoria and Queensland as well. If you sort of take out the jurisdictions and just think about the geology itself, like what are some of the signals for those that aren't sort of technically minded for where an area might, you know, have a red light versus a yellow light versus a green light in terms of this particular risk?
Yeah, okay. So any sort of coastal region, anywhere near rivers or the beaches, really your only option is to tank a basement, because you simply cannot build a structure where you're having inflows in the order of 50 litres a second or 200 litres a second. So that's one, 200 litre drum per second you have to try and manage. But every site's different. You might be in a coastal area on top of sands, but it might only be a couple of meters thick. So you could, what we're seeing more and more is what we call a partially tanked basement, where you would use a product like Dincel, but that terminates into a low permeability zone. So you're effectively tanking what's coming in the sides, but your base may be sitting in solid rock. So the amount of seepage coming vertically up into your basement becomes negligible. So depending on where you are, you may be able to do a alternate design. So that's why you need to, when you go and pick your site, get a due diligence hydro assessment done just to identify these high level risks and what you feasibly can and can't do. And then we also tack on the legislative component about what's your likelihood of getting approvals, the contamination aspect, where are you going to discharge it, all those sort of aspects.
And
if you go towards Western Sydney.
Yeah, sorry, Lee. Just adding to that is, once you've got that, then you would come and see us and we can design the best course option, if you like, whether it is fully tanked or a hybrid, as Lee talked about, where you're tanked into the flow areas and you're not tanked in the other areas.
Awesome. Guys, just a reminder as well, shoot your questions through the live Q&A section there. There's heaps of questions coming in, so we've got plenty of interest in this. Maybe just sticking with the kind of the geological elements, just for one more. Where's the mapping on this? Where do our listeners and developers out there, or any sort of professional services, where do they find this information?
Yeah, so Adam, it's a bit, it's state centric. So in New South Wales, there are some online portals, like your planning portal, but one specific for geology and groundwater aspects. So there's a website called MinView, where you can overlay the geology on a spatial map and you can look at sites. And this is sort of like a first pass where you can go, is my site sitting on deep sands where I'm going to get heaps of groundwater flow, or is my site sitting on shale and sandstone where groundwater inflows may be negligible and you can get away with not having to build a fully tanked structure? So that's, there's also in Queensland, there's Queensland Globe, and in Victoria and South Australia, there's similar websites where you can sort of do a bit of a first pass and see what you're up for.
Steve, from your point of view, what kind of developments typologies are most at risk here? There's a question here about greenfield development. There's not massive basements underneath those sorts of projects typically, but there will be some uses that might require that. Where's the Dincel product getting utilised the most? Is it those inner city sort of multi-unit residential developments, or is it a combination of things?
I mean, it's a combination of things because, again, as Lee said, water inflow is going to vary depending on where the development is. We're seeing significant amounts being used in residential detached buildings because as land becomes more expensive, we're seeing lockdown rebuild. I mean, Hawthorne, in inner city Melbourne, and also within, if you look around the Putney area within Sydney, knocking down an old house, and doing a duplex or two separate. And the way to make use of the land is to go down into the basement, and particularly we're seeing a lot of use down there, and particularly too, if you're talking about even a basement that has maybe it's not under the water table, but there could be seepage and what have you, that will then create a damp environment within the basement. And where you're having storage units underneath, or if you're actually having a habitable space underground, and we're seeing a lot more of that with underground film rooms and what have you. But if you've got a basement where you've got moisture down there and the moisture creates mold, and you've got people that are storing grandma's photos, can get ruined very quickly with some mold. So we're seeing a lot of our usage even in those areas where you're getting it's not submerged, but you're getting some seepage through there, and it significantly reduces the risk of any sort of water ingress, so reduces the impact of mold and so on and so forth. So from an amenity point of view, as per the NCC, it ticks that box as well. We're also seeing it particularly in those areas, those council areas within Sydney that mandate a fully tanked basement. So we're seeing a lot of that through there as well. But to answer your question, I guess, cut the point, we're seeing it across the range from detached to townhouses to multi-residential for both fully submerged and semi-submerged situations.
Yeah, you can't. There's no more land being produced, so we've got to go. We've got to go down, and we've got to go up. So you guys will be busy. Tell us about this. Tell us about this business. I mentioned in the opener that the organisation had developed this system in 2006. So it's 20 years ago. It's been tweaked and evolved, and obviously all of the compliance pieces with respect to the National Construction Code and all the other compliance and regulations that goes with it. Just give us a bit of an overview of the journey that you guys have taken to get to this point, and about the business itself.
Well, the product was originally developed as you said at the start in the early 2000s, where Burak Dincel developed the clip together system for ease of constructability on the way through. And the critical part through the whole Dincel journey has been about ensuring compliance. And initially, PVC fire was a big concern. So we've got a specially involved recipe, if you like, for our PVC. So we meet all of the requirements for fire and for smoke, both internally and externally on facades. Many people following the Grenfell fire and issues and the issues down at Lacoste down in Melbourne were concerned about the fire integrity of a PVC facade, but the PVC facade of a Dincel product complies fully. And so those were the critical issues that we were looking at previously. But water and water ingress has become more and more an issue that needed to be addressed. And we pride ourselves on the detail of our research and development that we undertake. And whilst the Dincel wall in and of itself is waterproof, that junction between the cold joint between the slab and the wall was always a weak point within any construction system. And so there was water ingress through that area, creating issues. So we spent our time trying to work out, how do you seal that area off? And we spent a number of years trying to develop our injectable system so that you can seal off the the water from that point. And it's a critical requirement to seal that water off. The other thing too that's most important about our system is if it does happen to leak for whatever reason, wherever the water comes in, that's where the leak is. So you can immediately address the leak, and you can address the leak from injecting it from the inside. With a conventional waterproofing system, if you have a leak, the water could be coming through from anywhere. And so it requires costly rectification, either excavation of the external side of the walls to repair membranes, so on and so forth, which is very difficult. It was our focus to try to make this system as cheap and as easily constructible as possible, but also in the long term, make it maintainable. And that's been our focus all the way through, and we will continue to develop our product to make it the best, cheapest, easiest construction methodology for developers and builders.
We've actually got it seems that we've got a couple of builder developers in here, or at least builders themselves, who are interested in understanding the warranties and how that interfaces with with the assembly process and the builders obligations to be able to do that. Can you take us through the dance there between you guys as a building system, the builder as the I guess the responsible party, and then the developer warranty come into that?
Yeah. Well, this is where we have to, first of all, we need to work closely with the lead specifier. And in most cases, I guess that's the architect, to make sure that the system is designed in so that you get the best design results for you. What happens then is that we have an internal team of construction specialists that work with the developer so that the Dincel water stop is cast into the base slab. And so we will then work with with whoever the formwork company is that the developer is working with, to make sure that the Dincel water stop is cast into the slab effectively. And we oversee that so that we can warrant that it's been installed correctly. We then have a number of approved Dincel walling installation contractors that we work with, and we would require that the developer utilises those installers to install the walling system, and we oversee that too. And so we oversee the installation of the Dincel wall, we oversee the installation of the self-compacting concrete. And it's critical that we do use self-compacting concrete, because that ensures that there's going to be no issues regarding voids, and you'll get full and complete compaction. And after all of that's done, and once the structure is fully loaded, then we come along and we inject the resin. So we have oversight of the entire process, and because we've got oversight of the entire process, we can offer this warranty. Now, this warranty of 50 years is initially it's a 10-year warranty. So you get a 10-year warranty, and then leading up to the 10th anniversary, we will come in, we will review the structure, ensure that there's been no issues that have happened, if you like, to the structure, and then we will extend it for another 10 years. And we will continue to do that for up to 50 years. Initially, the warranty will be with the builder, but the warranty is fully transferable to the ultimate building owner.
Yeah. And so just on the resin that's been injected, there's a few questions in and around that. Can you unpack that a little bit further as well?
I'm sorry, say again?
In relation to the resin that's injected by Dincel into
Yes.
the system, can you expand on that a little bit further as well?
Well, this is a third-party supplied resin, and they'll give an up to a 120-year warranty, which they've transferred through to us for that resin.
Okay. And so, guys, we're almost out of time. Gentlemen, thank you very much. There's heaps of questions that we haven't got to, unfortunately. What I do really encourage you to do is reach out to Steve and Lee, and I'm sure they'll be more than happy to answer your questions. Just in closing, I mean, you've touched on, both of you, two important things, and that's the first being that there's a kind of a delivery impetus to all of this, whether it be in the form of approvals, whether it be in the form of speed and actually being able to sort of deliver on a good project, and in time that having benefits. But then also at the same time, it's a de-risking element too from that perspective. Steve, do you have any kind of final words for our audience, just in terms of where to find you and how they can work with both you and Lee into the future?
I would suggest just dincel.com.au. We have a range of experts in this area. It's not just me. I'm kind of the Brian Henderson talking head of the organisation here. We've got a range of experts that can help you out in that area. But certainly, as Lee talked about, I would certainly encourage everybody to use a skilled hydrogeologist right up the front. And I'd also encourage you to get your specifiers, the architects, to engage with us right up front too, because if it's designed in properly at the start, then you'll get the cheapest or the most cost-effective, best solution in the long run.
And Lee, I'll give you the final word. Just quick word from you, some tips for the developers and the other professionals in our webinar this morning.
100%, as Steve said, get us in early. We can help you understand what the costs will be and help you minimize that cost from the very start and put you down a direction where you're going to de-risk yourself from both financially and construction delay risks. There's also some new approval pathway processes with the SSD HDA process, where if you do it right from up front, you can avoid having to get some of those approvals, which can save you 6+ months. So get us in early. We can get you on the right track so none of this stuff becomes an issue. You're not sitting on site with machines waiting around for months, and you can just get on with the job. So don't rely on your geotech report to give you the right information. Their investigation is purely for geotechnical reasons. I see time and time again that it's not quite targeted to the issue of groundwater, and big decisions, high cost decisions are being made on the groundwater aspect, how to construct your building, how much dewatering you need to do. So whilst, geotechs do a great job geotechnically, I would implore everyone to engage a specialist hydrogeologist just to help you work with the geotech, work with the architects, work with the designers, work with the structural team. And I'll leave it there, Adam.
Fantastic. Lee, Steve, thanks very much.
Hours.
Yeah, thanks very much for joining us today. Thank you all of you for tuning in. For those that are watching live, we've actually got 2 more webinars coming up today. We'll be unpacking Brisbane's proposed LMR zoning changes, which is coming up in about half an hour. And then we've also going to, just after lunchtime, be having a panel discussion on the Iran conflict and its impact on construction. So if you haven't registered for all of them and you're a member, please do so. If you're not, please become a member. And if you're watching this on demand, g'day, and thank you for tuning in. Thanks very much to our team, and thanks for you guys for joining us today. We'll see you at the next one. Cheers.
Cheers. Thank you.
Yeah.